Hi everyone, this is Charishma from Triple Department. Welcome back to the video lecture on structured query language, that is unit number 4. So in previous units, that is unit number 1, 2 and 3, we were very clear that DBMS is a kind of software which is used for dealing with the data, or I can say managing the data, huge amount of data that is stored in a single location. So this DBMS consists of different types of softwares, like I can say SQL, MySQL, Oracle, and among those, this SQL has got its own name in managing the database, especially the relational database. So what is meant by a relational database? Relational database is a store of data in the form of tables. There are many cloud database. So recent technologies also demand cloud database. But people by default, when they speak about a relational database, by default, their mind comes strikes the word SQL. So SQL is a default database language that is learned by the programmers to manage the data. So let me recall something from unit number 1 where we were speaking about DML, that is data definition language. DML, that is data manipulation language. So there we spoke about two different types of data manipulation language. One was procedural, the other one was non-procedural. So if you recall what is meant by procedural and non-procedural, procedural language is something where we speak about what data is needed and how to get the data. So here you are answering two types of questions. What are those? What data is needed and how to get the data are the two elements that we address in the procedural kind of language. Whereas in non-procedural database or non-procedural data manipulation language, there we just speak about what data I need. There I'm just bothered about what data is needed, and I'm not speaking anything regarding how to get the data. Here, what is happening in non-procedural kind of language, the compiler will take the headache of looking into the different ways and find out the best method to retrieve the data which is being demanded by the programmer using a query. That means a programmer writes a query and asks to fetch so and so data from the server, and the compiler will be looking into the different means of finding out the data, and it selects the best one and pulls the data out for you. Here the programmer is not bothered about writing the code how to get the data, like how it happens in C, C++ and Java. So this is one of the best advantage what you find in database management system, especially in the SQL. So now I can go for a straightforward line that this SQL what we are speaking right now is a kind of non-procedural language. It's a non-procedural language. That means you in your queries you just mention what you need, that's all. You need not write queries for how to get the data. So this is therefore a kind of a simplest kind of a simple language that plays with the vital advantages. I can say this is a kind of simple language in database management system with many advantages because it makes your work easier. So from the same point, it's very clear that this SQL can also be called as a declarative language. It is called as declarative language. If you look into each and every query of SQL, it would be something like the form of sentence, like how you write your general sentence. The same commands, the queries what you write over here will also be in the form of a general sentence which will help you in retrieving the data. That means the commands that you use over here are the common day-to-day words. Let's see how it happens in the coming slides. Now, let's proceed further and divide your SQL language into further languages. So this SQL concept what you're going to study here will be segregated into three different languages. Three different languages. And each type of language carries its own, each different kind of language carries its own set of commands. I repeat, each type of language in this SQL carries a set of commands, and these commands are in wholesome used for retrieving the data or creating the database or a table. According to the requirement, each of your command comes into one of these categories. Let's see how. So before that, look into the last sentence. Using the data definition properties of SQL, one can design. So you look into here, the data definition property. Data definition property means using DDL. Using data definition properties, one can design and modify the database schema, whereas data manipulation property, that is DML, here DML, the property allows the SQL to store and retrieve the data from the database. So last sentence gives a clear picture idea how this data definition and data manipulation language helps the SQL. However, these concepts were already discussed in detail in unit number 1. So let's proceed further. The same thing is being extended over here. I would like to recall one more thing for you guys is in unit number 2, we were speaking about relational algebra. Relational algebra. There I said like a relational algebra is a kind of a language which is used to write queries in SQL. In fact, I also said relational algebraic queries are not implemented in the system. See, these are something like the alphabets what you read in your childhood. So you read the alphabets and take the help of the alphabets to frame the words and then the sentence. Same way, relational algebra is also like a groundwork what you do and which helps you in writing your SQLs, and you are there, you have studied different kind of commands over there, different types of operators. Same operators will be applied over here also, so with a certain sort of difference. That's all. So let's move further. Before getting into the details of DDL and DML, we'll first look into the different types of data in SQL. Different types of data means data types, like how we have studied in C, C++, Java and all. So most of the data types would be matching over here also. So first data type is char. Char is nothing but the character string. Character string is nothing but the set of words, like you write your name, you write your institute name. So what does it consist of? It consists of the combination of alphabets. So any kind of words will come under a character data. But the difference is when the character string length is fixed. When the character string length is fixed, that is, you can see here n in bracket. What is this n about? This n is going to fix the value of the character. So for example, if I want the data that is entered over here should be of length 10, should be of length 10. In that case, whatever name or designation or whatever I'm entering over here, the length should be 10. That's all. The length is fixed. It should be exactly of a 10 value. It will neither accept a string whose value is less than 10 or greater than 10. It will neither accept less than 10 value or greater than 10 value. The length of the character should be fixed over here. So this kind of, if your data is of this nature, then you have to mention the data type as char and in bracket you just fix the length. Now let's proceed for the next data type, that is varchar. So fixing the length of a string is not always a good idea because each one's name or each one's designation or each one's course name, for example, will be of different size, right? The length won't be fixed. Some people's name would be short with four letters or 4 alphabets, or some people's name might be carrying about 20. In that case, you can't fix the length of the character. So what you have to do is you should allow the database to accept the values which are varying in nature, accept the string values which are varying in nature, which are varying in nature. So again, you can see here I have a value n written in the bracket. So what does it n means? Here the meaning of n would be little different. N is going to fix the maximum length of the character. Maximum length of the character. That means I would be saying the name whatever you are entering in this database, let the maximum length over there be 20. If the value is 20 over here, that means I'm fixing the value of n is equal to 20. In varchar, it is going to accept all the string values whose length is either equal to 20 or less than 20. Either equal to 20 or less than 20. Beyond that, greater than 20 is not accepted. Okay, so it is accepting the variable character string but of maximum length 20. That is so clear it is. Next one is int. You know what the int is, right? So int is nothing but the representation of numeric values without precision. So where do you get the precision value? If you say a number is set to be precise, that means you are mentioning something after a point. For example, I want a precise value of 2. In that case, I'll be mentioning 2 point something after 2. That means I'm trying to write my value in a much detailed manner. That is called as precision. But if your numbers, what you are entering over here, if it is not if it is not encouraging any point values and the value is a direct number, in that case you use the data type int. For example, age. Age cannot have point values, isn't it? So that kind of database, that data type is int. Okay, next one is numerics. So numerics is nothing but representing a fixed point number with the specified precision. It is quite opposite to what you have studied in int. So there it was no precision condition, but in numerics there it was no precision condition, but in numerics here you are mentioning the precision component. So in this precision component, if you are writing your value something in this bracket, for example, let's go to the example directly. You see, I have mentioned the data type numeric and in brackets I am writing 3 and 2. 3 and 2. What does it mean? That means whatever the number I am writing in front of zeros should be of maximum 3. 3 numbers. And whatever I write after my digit, after my point, this point, there should be of only 2 values. Same here, you look here, numeric of bracket 3 comma 2. That means it will allow 333.11 because the number of digits before point are 3 and maximum number of digits after 2 are 2. So it is allowing this type of number. But you look here, when I write my number something like this, triple T, the number of digits before point are 4 and after point are 2. In that case, it is violating the condition what I have mentioned in the bracket. Therefore, this kind of number is not allowed. So this is all about the numeric data type. Next one is small int. Next one is small int. So small int is a very small integer value. That means it is not going to carry huge numbers like 1000, 10,000 or so on. It is just going to carry a small integer values like it can be 1, 2, 3 or a single digit to 2 digit numbers. Why can't I use directly numeric? Why do I have a separate data type called as small int over here? The reason is to deal with the memory or to use the memory in an effective manner. You need not spare so much of memory for mentioning int. When I mention int, obviously it would be storing enough memory to store the value of that particular integer that we might enter over there. If in case it has saved so much of memory and you have entered only a small value, there won't be any memory efficiency or proper effective use of memory is not encouraged in that case. So what you do for that, you have specified a separate data type called a small int to encourage only small integer values. And next one is real number. So this real number will be allowing the floating numbers with a double precision. Floating numbers with a double precision. Floating numbers means repeating values that happens. For example, I can write 2.1, 2, 1, 2 and 1, 2. So how do I write this number? 2.2.12 bar. So double precision numbers. So if I want to encourage more than two double precision numbers, that is for n digits, in that case I can go for the data type called as float. So these are the basic data types that you use in SQL. Apart from this, there are many other huge number of data types those are used, but those are not used repetitively. So here we are here to understand only the basics of SQL, not getting into the details of SQL. So in this basics, you just need these data types to be understood in writing the queries. So let's get into the main topic of the unit, that is database languages in SQL. Database languages in the SQL. So I said I'll be segregating that into three elements, that is DDL, DML and DCL. DDL, DML and DCL. What is meant by DDL? DDL is a data definition language and DML is data manipulation language and DCL is data control language. So now let's look into the set of commands that can come under each category. The first one is the data definition language. I have measured three commands that are used in this particular category, that is data definition language, that is create, alter and drop. So if someone asks you a question, what are the set of commands in DDL, just say the answer create, alter and drop. So now we are bothered. So anyways, this particular command set of commands were already discussed in unit number 1. So here we are most bothered about the syntax, how to write a syntax of about each and every command in SQL form is the criteria. So just look into the first command, that is create command. So the syntax of the create command is create object type and object name. Create object type and object name. So what is the object type we have here? So object type can be a database, it can be a table or it can be a view. So I would like to make one more point very clear over here. So it's just like recalling what you have studied so far. What is a data definition language? So at which stage you use data definition language? Data definition language is used at the schema level. At the schema level. So what happens at the schema level? At the schema level, you usually design your database and also the tables inside the data and also the tables inside the database and each tables along with their attributes. Each table along with their attributes, and you would be creating a view over here. This is how my database should look. Is the condition, is the element what you're focusing at the schema level. So you're creating the database, you're creating the tables, at the same time you're also creating the views. So these are the three different types of objects that you have. So in that command create, you have to mention which type of object you're creating, whether you're creating a database or a table or a view, that should be mentioned, followed by the object name, what name you want to implement for that particular object. So just look into the queries over here. Write the command create followed by database. The database is object over here and tutorials point is the name of the database what you are giving for this particular object. And same way create. So these are three different set of commands. Okay, three different examples that we have taken: create, table and then table name followed by create view for students. For students, just observe here, I have not mentioned any space over here. So I just marked a underscore. What does it mean? So I'm trying to avoid the spacing between these two words, that is for and students. If I try to put space between these two words, it happens like this for is taken as a separate command and the compiler would be checking for the command, and if we don't find that particular command in the database engine, then obviously it will be in a dilemma and it will stop at the point where it has stopped its execution. So it will stop at that particular instant itself. So to overcome this, to make the compiler out of its confusion state, we never leave space between the unnecessary words what we have put in. So in the names, you better either remove the spacing and write straightforward, or if you want to make the name clear, you can use the underscore instead of space. So this is about create. So once you understand the create command clearly, then you can directly proceed for the drop command. So drop command, so what the name itself says, drop. So drop is something which is used to remove either the database or the tables or the views. Either the database or the tables or the views. So the syntax will be almost same to the create command. Instead of create, you just replace the drop over here. And then drop object type, object name, and the examples will be same like the previous one. And if you use this drop command, it is going to remove the database table or the views that has been created by the create command. Let's move further. Next one is the alter command. So if it happens like the schema what you have designed, that means the database view or the tables what you have designed at the schema level, if it has demanded some change, the client's requirement has changed and you want to make a change in the schema level, then in that case you use an alter command and make the changes in the alter command and make the changes in the database table or the views. So what is the syntax? The syntax is something like this. So alter, and then mention what you want to be altered, table, and then in that mention the table name, that is you see here, alter, object name is, object type is table, and the object name is article, and then you can put what action has to be taken. Add subject. You want to, so it means that you are trying to add one more attribute to the existing table. One more attribute to the existing table, and that attribute name should be subject. That attribute's name should be subject. And here you are mentioning the data type of the subject. So what can be the subject data type? Subject is first of all a string. Should it be fixed or it should be varying? Obviously it should be varying. In that case, what type of database you select here? Data type you select here, that is varchar. That is varchar. So what is that you're doing here? Using an alter command, you're trying to add one more column in this particular table whose name is subject and the data type is varchar. And in brackets, you can also mention the maximum length of the subject that can be allowed. So this is about the alter command. So all these comes under the category of DDL. So remembering the syntax is very, very, very important. And next, let's proceed for data manipulation language. So what is this data manipulation language about to do? So it is about inserting, updating and deleting the data. So before getting into data manipulation language, keep one thing in mind very clear, that is make one thing clear in your mind, that is this DML is working on the tables. it is now working on the table. Data manipulation language is something about working on the table values. The table is created. Who is going to create the table? It is by DDL language. And once the table is created, even the attributes are fixed over there. At which level? Using DDL level or DDL language. Once all these things are done, now you try to start your operations on the domains of the table. Domains in the sense each and every cell. So you will be working on the domains of the table. So these domains will be helpful, and these domains will be operated using the language called as DML. So operated in the sense the operation can be either select operation, it can be insertion operation, it can be update operation, or it can even be the delete operation. All these operations are encouraged now using DML language. That means whatever you're working on is on the table in the DML language. Why I'm stressing this point means in DDL language we had three data object types. What are the three object types we have seen? Views, tables, and the database. But here in DML language you have only one object type that you're working on, that is table. Now let's proceed further into each and every type of the command in data manipulation language. The first one is select from where condition. Select from where condition is like the project operator what you have seen. So it is very similar to the project operator of your relational algebra. Project operator, what is this project operator going to do? Is going to select, it is going to select the complete tuple. So this particular is select operator is similar to the projection operator of relational algebra. So when you mention about what to be selected, then obviously it should also mention from where it has to be selected and what condition should be taken into account to retrieve the data. So let's get into the example what you see here so that you can understand the concept. So you see here, what did I do? I've just written a select command over here followed by author name. So author name is the name of the attribute which you want as your output. You want the name of the author as your output. From where? From the table name, that is from the table name called as book author. From the table name as table name called as book author. So if I write just select from condition, in that case you don't imagine this where condition right now. You assume that where is not written now. You just assume that only select and from command values are queries are written. So I just mentioned select author name from the table name called as book author. In that case, my output will fetch me all the names of the authors, from the table called as book author. Now what did I do? Now I started giving a condition over there where the age is greater than 50. So what did I do here? I've given a condition. I say I don't want all the list of the authors in the table. Just filter out the names of only those authors whose age is greater than 50. In that case, the compiler would check for only those authors' name whose age is greater than 50 and filter out the data and keeps in front of me. Now I have only the names of those authors whose age is greater than 50. So I think now the role of select from where condition are pretty clear. So select is used to indicate what is required as your output. Here, like how you need your author name, that is your required output that you put for select. And from is the table name, from where you need to fetch the data. And then where is the condition carrier. Here you give the conditions so that you can get the accurate data over there. So in unit number 2, I was speaking about joins. When I want to retrieve the data from two or more tables, in that case, I have to join the tables, isn't it? So you can join the tables at the from condition, Join both the tables and indicate the name of that particular table in the from command. Let's move further. So once this select where from where condition is over, now you are into the insert command. Insert into values. The name itself says insert into values. So what is it going to do? It is going to insert the values wherever you want. So it would be something like this. So your syntax is something like this. You just write insert into, just write yes. So you just write insert into and then mention the table name. Just mention the table name. In that table name, mention the names of the columns on which the data has to be inserted. Follow the same sequence. You just mention the proper sequence of the columns on which the data has to be inserted, followed by the values. That means which values are to be inserted in the brackets. Now look into the example. Insert into tutorials point is the name of the table, and in that table you want the data to be inserted in the attribute names called as author, subject, and then followed by the values, and then in that author you want anonymous name to be inserted, and in the subject you want the computers to be inserted. That one you put in the inverted commas. So obviously the author's name will carry out anonymous, and then subject would be carrying out the computers. This is about insert into. And then next is about update set where condition. So the command itself says update set where. So this is used to update the values in the domains. So how to update or modify the values in the columns or the domains. So now let's get into the syntax directly. Just see, update is a command name followed by the table name and then mentions set. So this set will be used to insert the values in or change the values in a certain column name where along with the where condition. So this where is optional. If you want the where condition to be mentioned, you just do it, or else you can leave it. So here my condition is something like this. I want the author's name. I want to update the author details where all the anonymous has been written. For example, I have a table with the attribute called as author. So in that, one of the attribute is author, and in this author there are few domains. So for certain books, some author names has been written as anonymous. In that case, I want all the anonymous to be replaced by webmaster. In that case, I just use update command and give the table name and mention set operator and say the column name, and which should be equal to webmaster. So this is the new name what I am going to give, and where condition holds the old name where author is equal to anonymous. So this anonymous is replaced. So this web anonymous is replaced by webmaster. So this is about the update set where condition. Let's move further. So next one is the delete from where condition. So this delete from where condition is similar to select from where condition. Select from where condition. The syntax is also quite similar, and the name itself says delete. So you're trying to delete the values in the domains. You're trying to delete the values in the domains, and the syntax will be something like this. Delete from table name, and you just mention the where condition. So you see, look into the example. Delete from the tutorials point. Tutorials point is a table name, and where author is unknown. So you want to delete all those columns or all those domain values whose author name is unknown. So you want to delete the records of those whose authors are unknown. In that case, there won't be any record of the books whose authors are unknown. It's going to delete all those records. Now I have a question. What is the difference between the delete and drop command? What is the difference between delete and drop? So delete is something which is used to remove the records from a table. Delete is used to remove the records from the table. Whereas if I go for drop command, this drop is used on the schema. So it is going to delete either the complete database itself, a complete table, or a complete view. That means if I delete the database, the complete tables, the complete set of tables present in that database are also vanished. Whereas delete is not like that. Delete is something which is used to delete only certain elements of the table. It is working only on the table. Whereas drop is used to vanish the complete database itself. So this is the difference between drop and the delete. So next, let's go for the logical operators. So logical operators are mainly concerned to the command called as where. So I think it's very clear for you right now. That is where is a condition carrier. It carries the conditions. So when you have more than one condition to be written, in that case, you can use either and or not. So when you use and or not, when you have more than one condition, when you have more than one condition, then you can club all those conditions either by and operator or not operator. Now let's see when to use and, when to use or, and when to use not. So for example, if I have three conditions existing and I want to keep all the conditions in my query, in that case, if all the three conditions what I'm mentioning in the query are true, if all the conditions that I'm mentioning in the query are true, in that case, I have to go for AND operator. In that case, I have to go for AND operator if all the conditions are true. And among these three, if only one condition is said to be right, if only one condition is said to be true, in that case, I have to go for OR operator. And similarly, what about not operator? So not operator is a condition where none of these things are true. If none of those conditions are true, in this case I have to go for not operator. So the syntax will be something like this. So select column names, you just mention the column names from the table name. So select column name in the sense the columns which you need as your output, and then from the table name where the columns has to be selected, and then put the where condition. So if all the conditions are true, you just take condition 1, condition 2 joined by AND operator, joined by AND operator. So you can link n number of commands using AND operator, AND operator. So similarly, let's go for the next one, next syntax, that is syntax for OR. The syntax will be same. So select and mention the name of those columns which you want, and from the table name, and then all the conditions are mentioned in the OR. So let's go for not conditions. So not is also almost similar, where not and this mention the condition which is not true. So simple it is. Let's move further, that is order by class. So this is one more kind of command that you need to look into. That is, when you have n number of records, there are certain records that you want as your output, and you feel like the output whatever is being displayed should be in a proper order. Either it should be in an ascending order or descending order, or I can say the records should be in a well sorted manner. If the records what you want to be displayed should be in well sorted manner, there you have to use by order by class. and in that order by clause you have to mention you want it as ascending or descending order, whether you want it as ascending order or descending order. And I would like to say that this ascending and descending are not only applied for the numerics, these can also be applied for the string. And if I speak about the numeric values, there the ascending and descending order plays its role. But if in case of string, if I speak about ascending, then the arrangement would be from A to Z. And if you mention about descending, then the display would be from Z to A. The first Z records will be displayed followed by A record. This is how it works. And look into the syntax. The syntax is something like this. So select column name from, again, table name followed by order by clause, and you just mention the columns which has to be in the order. So all columns will be almost similar, same as what you write in your select command, and select order by the column, and you want whether it is ascending or descending. If you want ascending, you just mention as ASE, and if you want the data to be in the descending order, you mention it as DESC. Let's move further. Next one is the rename operator. So rename operator, as the name says, it is helpful in renaming any of the column or the table itself. You can give a new name to a column or a table. And let me tell you one thing, this rename operator is not like changing the permanent name of the table. You are not changing the table's name for permanently. It is only for simplifying simplifying your effort of writing the query. Sometimes the table names would be so long that while writing the query, the name of the tables or the columns so long again and again would be little inconvenient. To overcome this condition, we just rename the names of those big table names or the column names in a short form. For example, if I want to write the name of the student, let it be the student is a table name, and look here, the student name is, the table name is student, and if while writing the query, I need not write student and reserve again and again in a full form. Instead of that, what is that I'm doing? I'm renaming the name of the table student and the name of the table reserve as R and S. So I'm using the command as AS and renaming them. Student is renamed as S and reserve is renamed as R. And now I can refer them using s.name r.isbn. What does it mean? I am trying to pull the data of the names from the student table and the ISBN from reserve table. So S is nothing but the student, R is nothing but the reserve. Just mention the nicknames first and then elaborate in the from command. So this example is pretty clear, and let me remind you again. So as operator is used in the from command to rename any of the tables or the columns. And what is the use of this renaming? It is used for simplifying your work of writing the queries, since you need not write the long names again and again. Next one is about star, symbol star. What is the functionality of symbol star? Let's see. So when I write something like this, select star from student, select star from student. So what is it going to do? It is going to select all the records from the student table. It is going to select all the records from the student table. In previous case, we were just mentioning the names of the columns which I want to be selected. But here, when I mention it as star, that means it is going to select all the records. That means all the columns will be selected from the student table and displayed as your output. Next one is where clause predicates. So in among these where clause predicates, we studied about and operator, or operator, and not operator. So you have one more predicate that has to be studied, that is between. Between. So if it happens like in your where condition, you want to fix the maximum and minimum values, or maximum or minimum limit, and you want only the data between the maximum and minimum value to be displayed. In this case, you just go for the between clause and just mention maximum and minimum values over here. So next one is about defining the constraints. So this is alteration. So alteration was already studied previously along with the syntax. So this alter command is used to change the names of the columns in a table which belong to the concept called as DDL. This was already discussed. Let's move further to the defining constraints. So in my previous lecture, I spoke about these constraints. I gave a little description of why we need a constraints to be defined for any kind of. So constraints are set of rules. This will be helpful in framing your work in an effective manner. So these rules will tell you what to be done and what not to be done. At the same time, what are the important and crucial elements of your work. Same way, even the SQL deals with certain type of constraints what you have studied in unit number 1. The constraints are almost similar to what you have seen there. So the first constraint or the rule that need to be kept in your mind while writing or dealing with any relation or a table is the primary key. Primary key. So key is a very important element of a table. Why? Key is something which makes your data unique. For example, you have a student along with the attributes called as roll number, name, address. Roll number, name, and address. So which is that attribute which helps in making the data unique? So there's a chance of having same number, at the same time there's a chance of having same address. But the roll number, so roll number cannot be repeated. So the roll number is something which is unique. Same way, when you're trying to construct any table, in that case, there should be at least one attribute that makes the data unique or a record unique. So you need to define any of that element or that attribute that makes the data unique as your primary key. And keep in mind, there can be more than one key, but you have to select only one of among those key as your primary key. So if you are trying to implement the primary key concept in your query, how to write the query is the question. So here is a syntax, example syntax. So create table. So why did I say table here? So where do you define your constraints? Why am I mentioning object type over here? Because the constraints of creating or deciding the primary key works at the schema level. So at the schema level itself or a physical level itself, you have to define the constraint. That's why we are speaking about the object type here. So the object type for which you are defining the constraint is the table, and the constraint what you are fixing here is a primary key. So once you create the table whose name is person details, and in brackets you are mentioning the attributes of the table what you are creating. So for this table, I want attribute Aadhaar number whose data type is int, isn't it? Aadhaar number is a huge number and the data type should be int. It cannot be small int. And now followed by first name. The first name should be variable character whose maximum length should be 20. And then again middle name who's again a variable character whose maximum length is 20. And followed by address, which is again a variable character with maximum length 20. So among these three or these attributes, that is Aadhaar number, first name, middle name and address, I have Aadhaar number which makes the data unique. So I am mentioning this as a primary key. How to mention that as a primary key? You just continue with the query and write it as primary key, and in brackets you mention the name of the column which is taken as the primary key. So this is the best example which helps you in writing your DDL queries. So what command you have used and how to proceed with creating the attribute names and how to fix the data types, and then finally the primary key concept. Similarly, foreign key. So when I speak about primary key, obviously foreign key concept also comes into action. So this foreign key is again very important element to link up one particular table with the other one. So if you want to retrieve the data from table number 1 and table number 2, then there should be at least one common key between these two tables. Apart from the primary key, there should be one common key or common attribute between these two tables that can be referred with respect to the first table and to retrieve the data. The common attribute what I am speaking in my second table referring to the first table is called as a foreign key. So the foreign key helps in linking up the two tables for easy data retrieval. So same way, just go look into the example. I think the concept will be clear over there. I have the first table called as employee with the attribute names employee ID, name, age. And similarly, I have one more table called as department with attributes department ID, department name and employee ID. You just look into both the tables along with their attribute name and find out what that particular attribute which is common in both the tables. Look here, employee ID is present in department table and employee ID is also present in table called as employee. In this case, the employee ID is acting like a primary key in the employee table. At the same time, this employee ID is acting like a foreign key for department table. Foreign key, that means this employee ID is helping me to link the table department to the table employee. Now how to define the foreign key in a certain table is a question. So look into the example query over here. Just create a table called as department. Create a table called as department. And what are the attributes of the department table? Department ID and the data type is integer. And then followed by department name and the data type is varchar whose maximum length is 20. And then employee ID, again the length is int, and then followed by the primary key. What is the primary key of this particular table department? That is department ID. Then followed by the foreign key. So I am referring to the foreign key now. So this foreign key is the employee ID. According to my discussion, employee ID is my foreign key. So just mention that a foreign key is the command and in brackets mention employee ID followed by references. To which table is it referring? It is referring to the employee table with employee ID. It is referring to the table called as employee, which is carrying a primary key called as employee ID. This is how you have to define your foreign key. This is one more constraint. Next one is my unique constraint. Unique constraint. So unique constraint is something which is used to prevent same values in a column. Unique constraint is something which is used to prevent same values in a column. So it happens like there are two or more employees and in one that you want only one to have a manager designation. No two employees can have same designation. In that case, you can use unique constraint. If you give unique constraint, one employee can be given only one designation. No two employees can have same designation over there. So let's get into the example directly. Create table employee. Again, this is used at the DDL level. Create table employee whose attributes are employee ID, and data type is int, name varchar 20 and so on, and finally I'm mentioning unique constraint. So here I'm mentioning unique constraint to which attribute? The attribute called as designation. So this designation, when I keep it as unique, then obviously it will encourage only one type of designation assigned for one particular employee, where the primary key is employee ID. So this particular example is holding most of the commands and the way how to write each of these commands. Next one is not null condition. Not null condition in the sense, so there will be a case where certain attributes should not carry zero any value. So you should not allow null values over that. Null values over that. For example, you consider roll number. You consider roll number of a student. Can a roll number be null? Null means the domain which carries no value. Absolutely no. There should be some value inserted in the roll number column. In that case, what you have to do is you just mention that particular attribute as not null in not null. If the not null is assigned for a certain attribute, in that case, your database will not accept null entries. For example, while filling an application form, you can see there are few fields which are marked as star. What does it mean? Marked as star in the sense these are the mandatory fields. You have to enter some or the other value inside those fields. Otherwise, your application form will not be accepted, because these are said to be mandatory fields. That means these are not encouraging any not null conditions. Some value should be inserted over there and submit your application, then only it would be accepted. The database will accept the application. This is the constraint called as not null. So whatever the constraints what we have studied so far, that is primary key constraint, foreign key constraint, unique or not null, these are all mentioned at the schema level itself, that is your physical level. Next one is set operations. Set operations. So set operations were also studied in relational algebra, that is union, intersection and set differences. So let's apply the concept onto the SQL over here. So union operator is something which is acting like AND command, almost similar to AND command. And so if you have two or more queries to be written at a set of instant and you want to make both the queries to be acted at a period of time, in that you can club both the queries using union operators. So again, both the queries should be in a true form. So select column name, column 1, column 2 from table 1 and table 2 and just mention their condition over there, and then add one more column over there, and these two will be executed, Next one is intersect command. So this intersect is, So union operator would be used where one of those queries are to be executed. So you want only one query which is true has to be executed. So with the condition where the query whose where condition is satisfied, only that will be executed, the other one will be violated. Same way, I have an intersect command. So if you have two where conditions with a set of queries to be written, and both the conditions if they are satisfied, and you want the query to be executed, then you go for an intersect command. Both the queries are satisfied, then operate, then execute the program. So if you have such scenario, then go for intersect between the set of command, between select from where linked up by the intersect. Next one is except. So except is something like not condition. So if it happens like you want only one thing to be executed and not the other one, So if you want only one where condition to be you want all the where conditions to be executed except one where condition. So you say find out the names of the authors whose age is names of the authors except whose names start with S. In that case, it will pull out the data of all the authors except the names of the authors whose whose name starts with S. So remaining all alphabet starting authors will be records will be displayed over here. So if you have that kind of scenario, go for except condition. On if you have only one or where condition to be satisfied, either this or this. So if any one condition gets satisfied, show me the records, then you go for or condition. And if you say to the compiler, both the where conditions what I am writing here should be executed, then you go for an intersect operator to get the records revealed. Next one are the aggregate functions. So aggregate functions are something which allows you to perform the calculations, or you can do some arithmetic operations over the values inside a table. To perform arithmetic operations over a set of values inside the table, and it will give you one single value after the operation. One single value after the operation. So what are the different types of aggregate functions we have? Average, min, maximum, sum, count. So apart from this, you also have aggregate function called as distinct all. So average, minimum, maximum and total, sum and count. The name itself says what is the functionality of each and every type of aggregate function. So if I speak about average, it is going to pull out the mean value from the attribute entries, mean values from the attribute entries, for example, marks. So if I want to find out the average marks of all the students, in that case, select the column name that is average, and in brackets you just mention the column name that is marks. So it means to say get the average of marks column from the table called as student. Next one is count function. So count function gives the total number of entries made. For example, I have a table with the list of 4 students. I have a table with the list of 4 students records. In that case, how many entries have been made for me? 1, 2, 3 and 4. So there are around 4 students records I found in the table. In that case, the count is equal to 4. So in this way, you can go for the count both for numeric as well as non-numeric data. Whereas in previous case, if it is average, I have to apply the concept only on the numeric data. Whereas if it is a count, the entry can be happen for both the as well as non-numeric data. And in bracket for the count, if I go for star, in that case it is going to consider or count the records entered for all the columns. Next one is maximum and minimum condition. So again, the name says these are used to maximum value of a particular column. For example, select minimum of marks. If I want to find the minimum marks from the marks column from the table called as test, in that case it will give me the minimum value. And same way, if I replace minimum with maximum, I'll be getting maximum value of marks present in the table in a column called as marks from the table test. Next one is sum. The sum is something which is used to find out the total of any column, and this is again used for the numeric operators. This is used only for the numeric, and same way minimum and maximum are also used for numeric. Only the count aggregate function is used for both non-numeric kind of operators. Next one is group by clause. Next one is group by clause. Group by clause is used to group the rows that have same values. It is used to group the rows that have same values. That means a particular rows would be carrying same or similar values, and if you want to pull out all those records out and form a separate group, then you can use by group by clause. The syntax will work the group by clause will work in association with the select command. In association with the select command. Let's look into the syntax directly. The first one is select command. You just mention the name of the column which has to be selected, followed by the name of the table, and you just mention the where condition in this particular where clause. Now you want the data to be represented in the form of grouping according to their column names. The retrieved as your output should be arranged or grouped according to the column names is the condition. Let's go to the example and try to understand this one. So here I have a query. So for example, I have a table called as student, and in this table I'm having the attributes. I have attributes called SID, SNAME, marks, and city. In this, I want the total marks of the students who belong to a certain city. I want to determine the marks of those students, the sum of marks of those students who belong to a certain city. For example, consider, look here, find the total marks of the students in each city. So how many cities I have? I have 2 cities, that is Pune, and I say select the sum of marks, find the total sum of marks along with the city data. So I want the total marks and also the city data as my output. From which table? Table called as student. And what is the grouping clause that is given in the question? I want the data to be grouped by city. So that means the data of the Pune city will be summed up and the data of the Mumbai city will be summed up, and finally I have the 2 records displayed. 2 records displayed and 2 columns over here. Why 2 columns? Because in select command I have mentioned the sum of the marks and also the city. Only these 2 should be displayed. Therefore, my output consists of these 2 columns. And group by clause, if it has any condition to be added over there, then I can have having along with the group condition. So where condition is different. So this group by is used for group by if in case has any kind of condition, then it has to be used having. It cannot be, this condition cannot be written in where clause. The condition of group by should be written only in the having clause. Move further. Last and important topic of this unit is joins concept. So how is this joins going to help in SQL? Again, the answer for joins is always same. So whenever you use the concept of joins, it means to say that you're trying to retrieve the data from 2 or more tables. For example, you consider you have a student table and the reserve table, and you want the student name from the student table and course name from the reserve table. In that case, what you have to do, you have to join the table student and the reserve and try to pull out, to give some conditions and pull out the data of S name and course name. And important condition for applying the joins is it should have at least one attribute in common, like how you see here C.R.U.D is common between student table and reserve table. So there should be at least one attribute that should be in common. Let's go into different types of joins what you have. For the first one is inner join condition. Inner join condition. So other name of inner join is equi-join. The other name of inner join is equi-join. So this can be little clear with this Venn diagram. So I have table 1 and 2, and if I am applying the equi-join, the output what I am getting in the inner join is the data which is common in table number 1 and table number 2. All the data which is present all the data which is present in table 1 and 2 both will be displayed as my output using an inner join. Inner join. The syntax will be something like this. Select table name. So you're just renaming the table dot column name. So you're trying to pull out the data of column 1 from table 1 and column 2 from table 2, and this mention from table 1 inner join of table 2, from table 1 of inner join of table 2. At the initial stage of this session, I said from command carries out the joins. Same you can see here. So this from is increasing the joins. But you have to mention which type of join you are applying here. So you just say from table 1 inner join table 2, and just mention the condition over here on what the table 1 of common field is equal to table 2 of common field. So I already said for applying any kind of join, there should be a common attribute between both the tables. So that condition will be described using on operator, using an on operator. So on is something which works with the joins. Next is the left join. Next is the left join condition. So what is this left join going to do? So the left join is going to pull out the complete data of the table 1 along with the common data of table 1 and 2. The output of the left join is the total data of table 1, along with the common data of table 1 and 2, along with the common data of table 1 and 2. So this will be my output. If in case you find any zero values found in the domains or no values applied, in that case null will be displayed. While applying this join, if you find any empty domains where the value could not be found, in that case the null would be displayed over here. Next one is the right join condition. Similar to the left join, right join's output will be the complete table of table 2 along with the common data of table 1 and 2 is the output of the right join condition. The syntax will be something like this. Select table name along with the column name. That means you're trying to pull out column 1 data from table 1 and column 2 data from table 2, and in from command you just mention the name of the table along with the join. So which join you are trying to apply here? Table 1, right join table 2, and then go for on condition. On, just mention the common field that is existing between table 1 and 2. So this will pull out the data from the right table, and then you can see here, if I don't find any appropriate values, then the null will be displayed. So all the right table is joined with the left table, and as left table is not finding any appropriate data of that can be right, there the null has been displayed. Next one is full join. Full join is something that combines the results of both the right and left table. So the data of both right and left table will be displayed as my output in my full join condition. The syntax will be again same, just replace the join name. You just change the join name and you'll be getting the complete table. Again, if in case there is no appropriate record found, then the null would be displayed in each of the domains. So these are the important topics of structured query language, that is unit number 4. So hope most of the concepts are clear, and if each of the syntax of this particular unit are studied so far, then you can easily write the basic queries of SQL command, basic queries of SQL command. So next session we'll be discussing into the detailed aspects of database design, that is unit number 5. So thank you. Let's meet in the next session, that is unit number 5.